Michael, good morning everyone. Today we are going to discuss about the mechanisms of action of enzymes, right? Based on two hypotheses or two models, which is the lock-in key and induced fit hypothesis. All right, so without any further ado, okay, let's go on. Okay, mechanism of action and kinetics. Kita sekarang di bawah tajuk yang ini. Right, ini based on STPM, yeah, right. I'm not sure about the others, about matrix and SASI as well as air level, right. Okay, now enzymes mechanisms are based on, all right, lock and key model, which was proposed by Fisher back in 1890, okay, and then a few years later on, okay, Koshland, right, in 1959 proposed the induced fit model. Okay, which later on these two become lock and key hypothesis and induced fit hypothesis. Okay, right now the lock and key model, which was proposed by Fisher back in 1890, right? All right, so Fisher proposed that enzyme is bigger than the substrate in terms of size. Okay, and then this enzyme has rigid active site, as you can see from this diagram here. Okay, this enzyme is way bigger than substrate in terms of size, and this enzyme has rigid active site. I think in this sentence, student, you need to make some adjustment, right? Enzyme size is bigger than the size of substrate or substrate size. Okay, with rigid active site. Now, binding of substrate to the enzyme active site is specific, like you can see here, and is like a key fits into a padlock. Okay, this will form enzyme substrate complex, and the reaction is reversible. You can see, okay, the binding of enzyme with the substrate, okay, is very similar to the key that fits into a padlock, and this process is reversible. Okay, now substrate, okay, eventually changed into products and released from the enzyme. Okay, enzyme conformation, alright class, please take note, enzyme conformation does not change and free to bind with other substrates. So selepas enzyme ini sudah bind dengan substrate ini, enzyme akan membentuk enzyme dan substrate akan membentuk enzyme substrate complex. Okay, enzyme substrate complex. And then enzyme substrate complex ini reversible, boleh menjadi substrate dan enzyme balik. Okay, now enzyme akan digest, okay, substrate ini kepada products, dan enzyme tidak berubah bentuk konformasi dan bebas untuk bind dengan substrate yang lain. Okay, itu adalah BM. Right, so this is what was proposed by Fisher. Okay, now mari kita tengok model that was proposed by Koshland, okay, which is known as the induced fit model. Now Koshland said, all right, enzyme, right, is a 3D structure globular protein. Okay, and an enzyme has active site that is large. Nampak enzyme ini dengan active site yang sangat besar. Right, enzyme is a 3D structure globular protein with large active sites, and then the enzyme is flexible, okay, flexible and specific to the substrates. Okay, I think let me rephrase that. The enzyme, which is a 3D structure globular protein, okay, active site is large, and then the active site is flexible and specific to substrate. Ingat, ini agak mengelirukan. Okay, enzyme active site is large, and then active site is large, flexible. Okay, ini better. Okay, so enzyme's active site is large, enzyme active site is flexible and specific to the substrate. Okay, next, binding of substrate is complementarily. okay, to the active site. Nampak this substrate is the size of this substrate, okay, is complement to the size of the active site. Okay, boleh nampak substrate ni macam mana dia complement dengan size active site ini. So substrate can bind complementarily to the active site, and this will cause the active site to undergo a slight change in shape to accommodate the substrate. Why does the active site can undergo a slight change in shape? Because, as what I've mentioned earlier, the active site is flexible. Okay, so the enzyme active site is able to undergoes a slight change in shape to accommodate the substrate. But this is very on the contrary with the lock and key model. Okay, where Fisher said that the active site of the enzyme is rigid. Okay, tapi dalam induced fit, Koshland cakap active site enzyme ni flexible. Alright. Now let's go back here. So the active site, okay, enfolds the substrate. Dia mencengkam dan dia mengelilingi substrate itu active site. So the enzyme is induced, right, to undergo a slight alteration to achieve optimum fit with the substrate. Okay, maksudnya enzim ini dia terpaksa enzim ini punya active site terpaksa ubah suai sedikit untuk membolehkan active site ini bind secara optimum dengan substrate. Now, the substrates are held in active site by weak interactions. So, meaning to say, these substrates, okay, when they are already inside the enzyme, when the substrates are already inside the enzyme active sites, these substrates are being held or like stick, okay. These substrates are being stick into this enzyme active site by weak interaction, such as hydrogen bonds and ionic bonds. Okay. Next, the bonds within the substrates are broken and new hydrogen bonds are formed between substrate and the enzyme to form products. Okay. For example, if the substrate earlier was sucrose, eventually the product will be glucose and fructose. Okay. So the products cannot fit in the active sites of the enzyme, and thus the product are released. And then the active site of the enzyme is available, and enzyme is then reused to bind with other substrates that is complementary to the enzyme active site. Now, that is about the induced fit model and lock and key model. Alright, so this is about the rate of enzyme reaction. I talk about this in the next video. Right, bye.